Good day. I'm Loisse Albos, and I'm going to discuss about error detection by CheckSum. So checksums. This is a block code method where a checksum is created based on the data values in the data blocks to be transmitted using some algorithm and appended to the data. When the receiver gets this data, a new checksum is calculated and compared with the existing checksum. A known match indicates an error. In checksum error detection scheme, the data is divided into k segments, each of m bits. In the sender's end, the segments are added using 1's complement arithmetic to get the sum. The sum is complemented to get the checksum. The checksum segment is sent along with the data segments. At the receiver's end, all received segments are added using 1's complement arithmetic to get the sum. The sum is again complemented. If the result is 0, the received data is accepted, otherwise discarded. And to further understand the concept discussed earlier, here is an example. Find the checksum at sender and receiver for the following sequence. So here we have 4 frames, which is our k, so k is equal to 4, and each of the frame has 8 bits, so our m is equal to 8. And for the solution, at the sender's end, we add the first frame and the second frame, following the XOR table. So 0 plus 0 is 0, carry 1. 1 plus 0 is 1. 1 plus 0 is 1, plus 1 is supposed to be 0. So 1 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 0 is 1, plus 0, 1. 0 plus 1 is 1, and 1 plus 0 is 1. Then 1 plus 1 is 0, carry 1. So here's the carry. So since we have the partial sum, in order to get the sum, we're going to add the carry, which is the 1. So 0 plus 1 is 1. Then we just copy the remaining bits to the left. After this, we're going to add the third frame. So 1 plus 0 is 1. 1 plus 0, 1. 1 plus 0, 1. 0 plus 0 is 0, carry 1. 1 plus 1 is equal to 0, plus 1 is 0. 1 plus 1, carry 1. 1 plus 1 is 0, plus 1, 1. Then carry 1. 1 plus 1 is 0, plus 1, 1. And 0 plus carry 1, 1 plus 0 is 1 plus 1, 0, carry 1. So again, we have a carry here, so we're going to add it to the partial sum. So 1 plus 1, 0, and we're just going to copy the remaining bits. And after this, we're going to add the last and the fourth frame. So 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 0 is 0, carry 1. 1 plus 1 is 0, plus 0, 1. 0 plus 0 is 0, carry 1. 1 plus 1 is 0, plus 1. 1 plus 1 is 0, carry 1, plus 0 is 0, plus 1, 0. So we have a carry again, so we're gonna add the carry to find the final sum. So 1 plus 1 is 0. 0, so the final sum is 0, 0, 1, 0, 1, 1, 0, 0. And to find the checksum at the sender's end, we're gonna get the complements of each of the bit of the sum frame. So complement of 0, 1, complement of 0, 1, complement of 1, 0, complement of 1, 0, complement of 0, 1, complement of 1, 0, complement of 0, 1, complement of 0, 1. So we're gonna proceed to the receiver's end. And again, at the receiver's end, we're just gonna do what's the process we did in the sender's end. So we're gonna add the first two frames, but at the sum, I mean when we get to the checksum part, we're gonna add the sum and the checksum rather here. So 0 plus 1 is 1, 0 plus 1, 1, 1 plus 0, 1, 1 plus 0, 1, 0 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1, 0 plus 1, 1. So according to our concept, going back, if the result is 0, the received data is accepted, otherwise discarded. So for our example here, since the complement of the final sum of these two is all zeros, hence we accept the frames are accepted. And for our next example, again we have k is equal to 4 since we have 4 frames, and m is equal to 8 since each of the frame has 8 bits. For a solution, we're going to add again the first two frames from the original data. 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0, carry 1, 1 plus 1 is 0, plus 0 plus 0, 1, 1 plus 0, 1, 0 plus 1, 1, 0 plus 1, 1, 1 plus 1 is 0, carry 1. So the carry is written here. And we're going to add the carry to the partial sum. 1 plus 1 is 0. 1 plus 1, 0. 0 plus 1, 1. 1 plus 1 and we're gonna, after finding the sum, we're gonna add the third frame. 0 plus 0, 0, 0 plus 0, 0, 1 plus 1, 0, carry 1, 1 plus 1, 0, plus 0, 0, 1 plus 0, carry 1, 1 plus 1, 0, plus 0, equals to 0, 1 plus 1, carry 1, 1 plus 1 is 0, plus 1, 1. 1 plus 0, 1 plus 1 is 0, plus 0 is 0, and carry 1, 1 plus 0 is 1, plus 0, 1. Since we don't have a carry, we're going to proceed in adding the fourth and last frame. So 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 0, 0, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 0 is 0, and 1 plus 1 is 0, carry 1. So since we have a carry, we're going to add the carry first, and then we obtain the final sum. So 0 plus 1, 1, then we're just going to copy the bits to the left. So we obtain here the sum. So in order to get the checksum, just like what we did in the previous example, we're gonna get its complement. So here's the complement of the sum, and we call this our checksum. Then we're gonna proceed to the receiver's end, just like we did on the previous example. Again, we're gonna add all the frames from each of the frames from the original data, and then we obtain the the sum and its checksum. And again, we're gonna add these two to get the final sum using the XOR table again. And if the complement of this sum is all zeros, the data is accepted. So moving on to our third and final example, find the checksum at sender and receiver for the following sequence And just like our previous example, or blocks, and our m or n here is equal to 8 since we have 8 bits of each frame. So at the receiver's end, just like in the previous example, we're going to add each frames. So frame 1 and frame 2. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, plus 1, 1. 0, carry 1. 1 plus 0 is 1, plus 0, 1. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 0 is 1. Plus 0 is 1. Then 1 plus 1 is 0, carry 1. So we add the carry here to the partial sum. 0 plus 1 is 1. Then we copy the remaining bits to the left. And here, this is our third frame, and we're going to add it to our sum. 1 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, plus 0 is 0, carry 1. 1 plus 1 is 0, plus 1, 1. 1 plus 1, carry 1. 1 plus 1 is 0, plus 1, 1. Carry 1. 1 plus 0 is 0, is 1 rather, plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 0 is 1, plus 0, 1. So since we don't have a carry for this one, we're gonna directly add the fourth and last frame. So 1 plus 1 is 0, carry 1. 1 plus 0 is 1, plus 0, 1. 0 plus 1, 1. 1 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, plus 0 is 0, carry 1. 1 plus 0, 1. Plus 1, 0, carry 1. 1 plus 1, 1 plus 1 is 0, plus 1, 1, carry 1. So we're going to add the carry here to obtain the sum. So 0 plus 1, 1. And we just copy the remaining bits to the left. And in order to get the checksum, again, we're just going to get the complement of this sum. So our checksum is 0, 1, 1, 1, 0, 0, 0, 0. And at the receiver's end, just like we did in the previous examples, we're going to add each of the frame. And when we get to the part where we obtain already the sum and the checksum, we're just gonna add it again, following the XOR table to get this sum. So the sum is here, and if the complement of this sum are all zeros, then we're gonna arrive at the conclusion that we accept the data. So since these are all zeros, hence we accept the data again for this example. Summary. For error detection by checksums, data is divided into fixed size frames or segments. Sender's end. The sender adds the segments using 1's complement arithmetic to get the sum. It then complements the sum to get the checksum and sends it along with the data frames. Receiver's end. The receiver adds the incoming segments along with the checksum using 1's complement arithmetic to get the sum and then complements it. And for the conclusion, if the result is 0, the received frames are accepted, otherwise they are discarded. So thank you for listening.